Today, we're going to go over acids and bases in AP Chemistry. So, typically, the hydrogen atom in acids are typically positively charged, while the hydrogen atom in bases are typically negatively charged. And so, since fluorine and Cl have a -1 charge, hydrogen is going to have to make a +1 charge to bond with them. And in the case of bases, and those would be acids. And in the case of bases, the hydrogen charge is going to be a negative because sodium is a positive charge, and so to bond with it, hydrogen is going to have to be negative charge. So acids in a reaction typically form the conjugate base, and bases typically form the conjugate acid. And bases typically in reactions are proton, and when we say proton, we mean an H plus ion, which is basically just a +1 charge. They're proton acceptors, while acids are typically proton or H plus ion donors. So a perfect example is NH3 plus H2O, so ammonia and water. And basically what happens here is this is the base because it's NH3. Yes, it might look like it's giving away its proton, but no, it becomes NH4, which actually gains a proton. So that means this is going to be the base because the base is the proton acceptor, so it accepts the H plus ion, making an extra hydrogen, so H4 instead of H3. And the H2O is going to lose its proton or donate its proton, and basically that means it's going to be the acid. So it's going to go from H2O, 2 hydrogens and an oxygen, to 1 hydrogen and an oxygen, which is basically going to have a negative charge because you're losing the +1 charge from the hydrogen that you lost. So it's going to be the proton donor, H2O, as water is. So let's do some practice problems. So find the conjugate acid and the conjugate base for HSO3, HCO3 minus, and H2O. And keep in mind SO3, CO3 minus are all polyatomic ions. Alright, so hopefully you did that. Hopefully you found the conjugate acids and bases, but if you couldn't, then that's fine because we're going to go over it right here. So for HSO3, if you're finding first the conjugate acid, what you're going to have to do is basically give it a proton, right? Because the base is the thing that gets the proton, it's the proton acceptor, and the opposite of the base is the conjugate acid. So to find the conjugate acid, you're going to add an H plus atom, ion, and you're going to get an H2SO3 instead of HSO3. So now there's 2 hydrogens, so there's an extra H plus ion. And for the opposite, what you'd do is you'd basically remove the H plus ion or the H atom, and because in this way this HSO3 would function as the acid, and the conjugate base, which is going to be what comes after you remove an H plus ion, is going to become SO3. So in this case, I actually drew them both on the same slide on this one. So HCO3, right? Conjugate acid is going to gain a hydrogen, so it's going to be H2CO3 plus, and the conjugate base is going to be CO3 minus. It's going to lose that hydrogen, so it's going to become just CO3. And keep in mind, in this case, because it's the conjugate acid, this HCO3 is going to be the base, but in a case like this, since the HCO3 is the conjugate base, the HCO3 is going to be technically the acid. So the actual same molecule can actually function as both in different situations. So you have to just keep note of that. And in the last case of H2O, water, and this is our last example, the conjugate acid of water is basically going to be H3O plus, the hydronium ion, and that's going to be the base in that case. When it's an acid, it's basically going to form the conjugate base, which is going to mean it loses an H plus ion, and it's going to create that OH minus or hydroxide ion.